RAG security fails when retrieval happens before authorization. OpenFGA lets you filter documents by permission before the model ever sees them. This is the pattern you'll be able to implement by the end, which checks document access for a user and searches only permitted texts to answer a query. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Retrieval augmented generation breaks when the system hands irrelevant or forbidden documents to the model. In practice, that means leaked answers, poor compliance, and wasted compute. The idea here is simple. Check who can read what before you run any expensive search or call the LLM. Success looks like a user receiving an answer drawn only from documents they are allowed to see, and a short, safe candidate list for ranking. At a high level, OpenFGA is a lightweight authorization store. It stores the rules and the tuples that say which users can access which documents. Instead of computing relevance across the whole corpus, we ask OpenFGA which object IDs are allowed for the user, and then score only that subset. That keeps the model from ever seeing forbidden text and reduces unnecessary scoring. We will build a small toy flow that shows the full pattern end to end. You will see provisioning, publishing a model, writing tuples, a naive unfiltered search to demonstrate the risk, then the safe prefilter and a wrapped search function. I will keep the code tiny and the ideas focused so you can adapt them to bigger systems. Now we will provision an OpenFGA store. This snippet connects to a local OpenFGA server and creates a new store. The variable base URL points at the OpenFGA HTTP API. A post to the store's endpoint provisions a store and returns an identifier, which is saved in store ID. A quick get to /healthy confirms the server is healthy and reachable. The print shows both the created store ID and the health status, so you know the backend is ready for subsequent writes and queries. Seeing a 200 with a real ID means you can proceed to model and tuple operations confidently. Next, we will publish the authorization model. This code publishes a minimal document permissions model to OpenFGA. The body variable defines two types, user and doc, and a single doc relation named reader using this, which means access is granted by direct tuples. Including schema version set to 1.1 tells OpenFGA which syntax to expect. The request posts to authorization models in the created store and returns an authorization model ID captured in model ID. You will reference this ID when listing permitted objects. The printed ID confirms the model is active and ready to accept tuples and permission queries. Now we will write some tuples and run a naive search to show the risk. This example writes who can read tuples to OpenFGA and runs a naive search. The list tuples pairs users to documents. Then TKS maps them into the tuple keys format for relation reader. A post to write stores these relationships in the current OpenFGA store. The dictionary docs is a tiny corpus, and scores counts how often the query term budget appears in each document. The variable bid selects the highest scoring document across the entire corpus, ignoring permissions. The printed naive _top reveals the unfiltered winner, which can easily be a document the user should not see in a production RAG flow. Next, we will pre-filter using OpenFGA and then score. This snippet pre-filters document candidates using OpenFGA before computing relevance. It calls post/list objects with model ID, the doc type, the reader relation, and user Alice to obtain only readable object IDs. The set allowed is converted into canned by filtering the docs dictionary to permitted entries. The same simple term count scoring runs, but now only on the filtered pool, making the selection safe to show. The final best ID bid is guaranteed to respect access rules. The printed result confirms both the top permitted match and how many documents were considered, illustrating safe narrowing of the search space. Finally, we will wrap this into a reusable function. This code wraps permission-aware retrieval into a small function. The function search calls OpenFGA's list objects with the current model to fetch allowed documents for a given user. If nothing is allowed, it exits early, avoiding wasted scoring work. Otherwise, it filters the docs dictionary to only permitted items and computes a simple frequency-based score against the query. It selects the highest scoring candidate and returns both ID and score. Increasing query specificity typically reduces ties and sharpens selection, while broader queries may consider more documents. The printed hit shows a safe, final recommendation that respects OpenFGA permissions before any ranking. In a real system, this maps to your document store by replacing the ToyDocs dictionary with your index metadata and running the list objects call first to produce the candidate IDs you will fetch from the index. Recap. What it is: a workflow that consults OpenFGA to list allowed objects before any retrieval. When to use it: whenever you must enforce fine-grained access control in a RAG pipeline. One caveat: you still need to secure the model output path and validate that the model does not hallucinate protected facts. Wrap punch. Next step: scale this by swapping the simple count score for an ANN index and measure latency and accuracy as you increase corpus size. If short practical AI engineering helps, subscribe and watch the AI engineering videos.